Good morning, everyone. Thank you for attending our Stacking Radian and FXR webinar from OutBack Power. It's just about 10 o'clock, but it looks like a few people are a little bit late, so we'll give them just a few more minutes and then we'll get started. Thanks. All right, good morning again, everyone. Thank you again for joining us. We're going to go ahead and get started. It looks like if people are going to be here, they're here. So my name is Kim Foster. I'm an applications engineer here at OutBack Power, and with me is Lonis Tuss. He's our senior field support engineer and knows a lot about stacking, so I asked him to help me out. So just a few ground rules. It's a little hard for us to monitor questions as we go along, but we will do our best. So if you do have a question when it comes up, feel free to write it in, and then we'll try to get to it. If not, we'll certainly get to it at the end. And I think that's it. So let's go ahead and get started. All right, so stacking basics. What is it? What is this thing that we call stacking? Basically, it's one system with multiple inverters. So you can create a larger power system with smaller powered inverters. So if you have two 8048 Radians, each one is 8 kilowatts apiece. So together they can create 16 kilowatts. And then along with this, they coordinate the function of all the inverters. So they all coordinate together to create a common output, and they share AC sources. Okay, so the next part, information you need before you get going on your system and really physically putting it together. So in addition to the manuals, the batteries, all the equipment, is it appropriately sized? So this is a problem that we run into pretty often, especially with stacked systems. We want to make sure that our battery matches our PV and that matches the load profile, and that the inverters can support all of those things. So
yeah, and basically with an inverter, you should size the inverter to be able to run the surges required by the gear. So if you've got each Radian can surge up to 16K and almost 17, and the FXRs can, the 120-240 volts can go up to basically 6K. So, the inverter should be sized to run the load surges, and the batteries need to be sized to run the loads for the amount of time required, and the PV should be sized to not only run the loads during the day, but charge the batteries so they can continue to operate during the evening.
Thanks for that, Linus. So the next couple of things, are you planning to connect on optics? That's a good thing to know before you get started. And in our opinion, you really should. In case you're not familiar with optics, that is our remote monitoring platform. And you can put two systems together. You can see the whole stack on there. And it's just really helpful, especially when if you need to call technical support, then that is the most direct way for them to see your system and get the most information and help you out quickly. Otherwise, we're asking a lot of questions. We're not shooting in the dark, but it's pretty close because we can't physically see your system. So that's why optics is really very, very helpful. And if you have the ability to connect to optics, you should. A couple of other questions here. So are all your wire lengths equal? That's also very important. You just want to make sure you have all those measured out and planned well before you get started. And then the final one is the verification of phase relationships. And I'll let Linus talk about this one.
Yeah, and one thing that we've seen, well, 2 or 3 times a year, and I know that's not a lot, but it's very expensive not to pay attention to. 2 or 3 times a year, we get someone calls up and says, hey, your inverters invert just fine, but they won't connect to the AC. And what generally happens is they put in an inverter and they have a 3-phase source. And if it's a Radian 8048 or a 4048, it cannot connect to a 3-phase source. It has to be a 120-240 input, and we'll run the 120-240. So what happens if you're lucky enough to do the FXRs? Well, then you could just simply say, hey, guess what? You're 2 legs of a 3-phase system. But with the Radian, and this has happened quite often, they put it in, they measure 120, the other leg's 120. It's an oddball type voltage situation, and you end up with a 3-phase, and now the installer has to foot the bill for a transformer to change that input to a 120 so the Radians can adapt and use it. So not only, it's just good to actually know what you're dealing with. You would think it's obvious, but it happens 2 or 3 times a year from some very experienced and good installers. So just a word of caution.
Okay, so now that we've gone over the information that you need, in addition, again, to those manuals and quick start guides and all the physical equipment, now we'll get into the nuts and bolts, really, of after you have it all set up, it's on the wall, it's all connected, everything's good, you're ready to turn it on. So there are 3 basic requirements, and we'll go through each one. And we call these basic requirements because they're the main programming screens that you'll see on the Mate 3S to successfully stack a system, whether it's Radians or FXRs. So that's why we call these basic requirements. So the first one we'll go through here is the inverter stacking menu. And we've put a mock-up Mate 3 screen on the right side of the slide here. And if you want to know where to find this screen, you can go to the OutBack Power website and download the Mate 3 menu map. I find it's the most helpful when you're trying to navigate through all the screens, because I know there are a lot. And if you print it out on an 11 by 17 page, preferably in color, but doesn't have to be, it's just a really handy reference to keep next to the mate, or keep wherever you have all your good references that you pull out when you need them. So again, if you want to know where to find this inverter stacking menu, go to that Mate 3 menu map and navigate through all those menus. So what does this menu do? It assigns a phase relationship within a system. So this one, there are 5 options. They're listed here. We have it on the right as the master. So master, slave, and then a couple of different options for 3-phase or split phase systems.
So if you have a single inverter, it always goes into port 1 of the hub, and it's called the master. If you're in a 120, 240 volt configuration and using a FXR, you call the second phase the L2 phase master. If you have parallel stacked inverters and they're hooked up behind the master or the L2 phase master, you just call them slave inverters, and they will follow whichever master they're assigned to. And again, with the 3-phase system, hey, I've got 3 phases coming in, a master, a B phase, and a C phase, and it will line this up into a true 3-phase system. Each one will put out, with the FXRs, each one will put out 120 volts, and between the 3 masters or the slaves attending the masters, they will be a 120/208 system. We only use a 3-phase Y system. We do not use Delta.
Okay, now that we've covered the first requirement, we'll go on to number 2, and that is the Powersave level menu. Again, you can find that on the Mate 3 menu map there, but the Powersave level and the stacking menu are very close together. So Powersave level, this menu tells each inverter that it will turn on in this sequential manner to support the loads. So FXR inverters, it commands each slave to begin or stop inverting. And then for Radian inverters, it's a little bit different. So if you've ever looked at an 8048, which I'm sure a lot of you have, there are 2 power modules. So the Powersave level actually tells each module when to begin or stop inverting. And then if this doesn't make any sense, we're going to go into it right here.
So in this configuration, we have a parallel stack of Radians, and you have one in the master inverter and goes 1, and you just label the slaves 2 and 3. So these power levels turn on in a 120/240 volt Radian at 12, and the FXRAs at 12 AC amps. So when the master inverter is sitting there at idle at night, only one of those modules is on, and it's, you know, it's about a 30 watt tear loss. So if all the inverters would on, you would have 30 watts per module. So it's really nice to say, hey, at night when there's no loads, one module puts out 120/240, and I can run these loads. But as the power level increases, it gets up to 12 AC amps. It says, hey, I've got this other module sitting here, I'm going to turn that on. And so you have module 1 and 2 on, and when now you reduce that 12 amps to 6 AC amps, and when the master module sees 12 AC amps, it says, hey, turn on the next one, and it just sequences on that way. And as your loads increase, more modules will turn on, and as they decrease, they will turn off. So it will vary itself throughout the day, on and off, due to the powers.
So you can also see, so what Lonis just described in words, you can see here on the right side of the screen where we have the 3 Radians that are in parallel, and each module has an on or an off depending on which, what the power level is. So like Lonis was just saying, if you're not doing anything and the inverters are just kind of sitting there at night, we'll be on that top line where module 1 will be on and everybody else will be off. And then again, if the master sees 12 AC amps, it'll turn on module 2, and then so on and so forth. All right, so we've covered basic requirements number 1 and 2. So the first one being the inverter stacking menu, the second one being the Powersave level menu. And now we'll move on to our third and final requirement, that is having a hub 10.3. So this gives the phase masters and slave inverters instructions and who to listen to within a system. There are also 5 jumpers in the Hub 10.3. You can see the different configurations in the quick start guide, but it's really very important to get these correct for stacking.
Yeah, and where this came about is as we always had a 4 or 10 port hub, and up till the FXR and the Radian, we started increasing the capability of the units. And the question became, do we make a hub with 20 ports, 30 ports? Do we daisy chain these hubs so that we can daisy chain them? And what happened is once we had optics, we just said, let's make a new hub. It's called a 10.3. And where you put the jumpers in there, we'll assign the slave inverters to a master. So if you have a 3-phase system and you put the master in port 1 and you call slave 2 slave 1 and port 2 slave 3, they will turn on from the master to the second module to the first module in the slave to the second module in the second slave, and they will just turn on sequentially through the ports. So potentially you could have up to 9 inverters here, and they will sequence on and off based on the masters in port 1, 4, and 7's power requirements.
Okay, so now we're going to see who's been listening. So again, we just went over the basic requirements, so keep those in mind. Hopefully you took notes. So you should see a poll on your screen. So just click the one that seems most correct, and we'll go over the answer in just a minute. Okay, so it looks like almost everybody has voted. So I'm going to go ahead and close this poll. And here are the results. So good job to most of you. You got it right. It was the last answer, C, the basic requirements for proper programming. That was the key phrase there, proper programming. A Hub 10.3, the Powersave menu, and the inverter stacking menu. So the other, I did try to trick you up a little bit. So the other 2 answers are correct for an entire system, but not necessarily required for proper programming. So that, again, was the key phrase there, proper programming. So charge controller, rapid shutdown are not, unfortunately, part of the programming that we were going over. But it was a very good job nonetheless. So now we'll move on. Okay, so now that we've covered our nuts and bolts and the requirements, we're going to go over the physical connections that we're going to make between our inverters and our Hub 10.3. So, like Lona said earlier, we'll start with the master. He is always going to be connected to port 1 of the hub. Always, always, always put your master inverter on port 1. And you can see that here on the right, we have a small diagram Just run that cable right to port 1. All right, step 1 is complete, easy. Step 2, we're going to work on slave inverters, and then we'll get to a three-phase system a little bit later in the PowerPoint here. So for slave inverters, if you're, we're just talking about Radians for the moment, you can stack them and connect them to hub ports 2 through 10. And then we have both the inverter stacking menu and the Powersave menu here on the screen as well for slaves. So inverter stacking, again, we're going to change that from master role to a slave role for any and all inverters that are not the master, specifically with Radians. And we'll change our Powersave level to 1 through 10. So initially, I think it says 0. Correct me if I'm wrong, Lonis.
I believe the slave power level starts out at 1.
Oh, okay, thanks for that. So you'll be 1 through 10, and you'll just increment as you go along.
So what kind of happens is, as the, let's do an FXR right now. All right, so if I have a master inverter in port 1, when it gets to 12 AC amps in a 120 volt configuration, it's going to say, hey, you know, I've got 12 AC amps, I'm right at my mid power band. Instead of working harder, why don't I work smarter? So it just says any slave of level 1 turn on. So it'll sequence on the slave level 1, and then when it sees 12 AC amps again, it sequences on slave level 2. So you just stack them up one consecutive higher, and it will turn each inverter on as it gets to that power save level. And the same with the Radian, basically, except it works by module then. So if you have a Radian, there's 2 modules in there. When the master sees 12 AC amps, it says, hey, give me the next module. And then it turns on its second module. When it gets to the next power save level of, you know, another 12 AC amps on top of that, then it says, all right, now turn on the next module. That's going to be the slave designated as 1. And so it just sequences on and off, very logical manner. So in a 3-phase system, well, let's see here. Nope. Okay, this is the power save ranking. And again, you can see this. The stack mode on port 1 is a master with a power save level of 0. Port 2 is a slave with a power save of 1. Port 3 is a slave with a power save level of 2, or yeah, 2. So it's the 3rd inverter, but the 2nd level of power. So that's how they'll sequence on.
And just to point something out here on this screen, we combined these menus for clarity because there would be 6 different menus on this one screen. So we did combine them. They are separate menus on the Mate 3S. So just to make that point clear.
So on the ESeries, they are the only Radians that can be set up as a 3-phase system. Because they have a single voltage output, neutral to hot is 230. So they can be set up in different phases into a 3-phase system. So you can use up to 9 inverters on a 3-phase system. And also the FXR and the FXEs can be used in a 3-phase system. It would be a 120 208 or let's see, a 230 408, I believe it is. So that's, yeah.
And the same rules apply here where step 1, if you're stacking E-series models, then you would put the master into port 1. That never changes. It doesn't matter what inverter it is, the master always goes to port 1. Oops, sorry, that was an accident.
So in a three-phase system, again with the FXRs, the FXEs, or the Radian E's, what you do is the way the phasing are adjusted is you're using the hub to direct things. The master always goes in port 1, the phase B master goes in port 4, and the phase C master goes in port 7. And again, there's jumpers inside there, inside of the unit that you can adjust to make this into a three-phase system, whether it's a Radian or an FXR. So that's, yeah. So now this is kind of a messy screen, and that's the way I operate. So here is a three-phase system. It could be FXRs, could be FXEs, or it could be Radian-E's. Port 1, you have the master. In port 2, you say, I've got a slave. In port 3, I've got a slave. And those three inverters work together. It just says, all right, if I'm the master in port 1, and this is what came about with the FXRs. In the older systems, the FXs, we could do 3 inverters on a three-phase system. By going to the R, this gave us the ability, and changing the hub, it gave us the ability to say, I want 3 inverters on each phase. And the master in port 1 says, hey, when I need help, I'm going to turn on the slave in port 2, designated as the slave 1. When I need more help, I'll turn on the other slave. And each one of these masters looks at the voltage and the load on its phase. They will maintain phase B and C will maintain their phase relationship to master in port 1, but it'll turn on and off in sequence the inverters, the slave inverters that are attending to it. And what this gives us is a much better voltage regulation. Now you could say, hey, I don't have any loads, a very low load on in B and C, but suddenly the master is seeing enough inverters that I have to turn on all the slaves on port 1, or I have to turn all the slaves on the B phase, or turn on all the slaves on the C phase, and the other adjacent phases are just still putting out what they require. So it gives us much better voltage regulation and power monitoring than we ever had before.
So I know this has been a little bit, it's been kind of a lot in a very short time span. So I just want to make sure that nobody has any questions on what we've just gone over, especially this three-phase stack. It is a little more complicated than your run-of-the-mill 2 or 3 stack Radian 8048As. So just want to make sure everybody has their questions answered before we move on to something else.
So one thing that if you're commissioning, say you have a stack of inverters, and it could be a 10 stack of just a parallel, or it could be a 9 stack of inverters in three-phase. When you commission something, what we see happening, because the slave inverters will not turn on unless they're commanded to. So a good thing to do is give the units DC power, turn off the inputs, the AC inputs and the AC outputs so they're not connected. And then you can go through the power save levels and turn on every inverter and do the phase relationships. So what we see from time to time is, hey, this guy hooks it up, he turns it on, he's got low power, everything seems to work, gives it an AC input, it passes through. And what's nice to do is to, without an AC input, is to sequence each and every inverter on. So all of them are on and outputting power. And then you can check the phase relationships between each one. If you swap the wire and now phase 1 is going, or L1 is going to L2 somewhere in the inverter system, this is a good point to find it. And with the FXRs, you could say I'm going from neutral to hot on each one. Yep, they're all 120s. Now I'm going to go from hot to hot on each one. It should be 0 volts if they're in phase. And you can check to see for any wires that have been swapped before you actually turn a load on. And because they're not physically connected, they're disconnected from each other through the breakers. They're not physically wired to the others, but they are still following the phase relationships, which is a mouthful to say. I hope that helps.
Well, it looks like we don't have any questions just yet, so maybe they'll come up with questions later on.
Okay.
Okay, and then continuation again from the previous slide, we're just showing you the Powersave rankings here. So again, these have kind of been put together for clarity. And you can see Powersave level is 0 for each of these masters.
Yeah.
So those will all be on at the same time.
Yeah, and what happens is the master says, okay, so this is where you could sequence units off in the last thing I was talking about commissioning. So if you have, say, the Powersave ranking on port 1 is 0, that means, hey, only the left module's on. So if you have 2 slaves adjacent to it, you're going to say, well, I want both modules to be on. So I'm going to go to Powersave level 1. You can check the output then. You can go to Powersave level 2, and it will turn on the slave 1's left module, and you can sequence this Powersave level on and turn on every slave and measure the phase relationships before you hook it up live to loads. And you could, once they're all on, you can sequence that back down to 0, and you'll hear the inverters turn on and you'll hear the inverters turn off. It's just a good thing to do if you're commissioning a system. How do I know every wire is going where it belongs? Well, check it.
Okay, so now that we've gone over the basics of programming and a couple of different examples, we'd also like to show you just this one screen from Optics RE. So you can also change your Powersave levels in Optics. So this is a screenshot from Lonus's own system. So you can see he has one Radian, and it is the stack mode is master. And you can see that there on the bottom of the screen where it says stack mode. And then our Powersave levels are set as appropriately. The reason you can't change your stacking mode via Optics, so remotely, I will let Lonus talk about.
Yeah, and the stacking is part of the physical arrangement of the wiring. So to allow that, if say you have an inverter, an FX, and it's wired to port or to phase 1 or phase 2, if you were to change that in Optics, it's due to the physical wiring. This inverter is physically wired to L2 in a 120/240 volt system. So if you were to change that in Optics, you would have a dead short and the whole system would fail. So we won't allow stacking. There's some things that have to be done when you're installing and commissioning the system, and that is the wiring. So you can change the Powersave levels, but not the stacking assignments.
Okay, so that was all the content that we had for you today. The last thing, we'll go over any questions you have, and then I have one more poll for you once we get done with our questions. So it looks like there's one question. Oh, there's more now. Okay. So with 2 FM100 charge controllers and 2 Radians, what ports do the controllers go to? Doesn't matter. I mean, just for organizational principles, you could do master Radian, port 1, slave Radian, port 2, charge controllers down the line. So it's pretty simple. Okay, next question. How are you able to monitor other pieces of equipment, charge controllers, FNDC, after you have filled all your ports on the hub?
Excellent question. And what we've done with that is, as I stated earlier, when this question, we started getting much larger systems, 10 inverters, and then, well, you buy another mate and another hub, and you put all the charge controllers on there. And if you have a battery monitor, the FNDC, we generally recommend that goes with the equipment tied to the inverters. So what would happen is you can marry these in Optics, and it's pretty cool. There is a white paper that has been written about that. I believe Roy Dingen wrote that. and it should be, I believe it's available on our website. But what it does now, say I've got 10 inverters and a FNDC or a battery monitor on one hub, and I've got 10 charge controllers on another, I can take those two systems and marry them together in optics. So I could view them as single systems. I could go to the mate with the inverters. I can go to the mate with the FN or the FMs and see either one, or you can see the aggregation of both of them together. So virtually you would be looking at a single system and how it's operating on optics. Okay. Next question is, great job. That's great, thank you.
So the next question we have is, with multiple Radians, how do I wire the FlexNet DC?
Okay, the FNDC is our battery monitor, and it can monitor 3 shunts. And what it does, there's not a master shunt, there's simply 3 shunts, and it does the math of what it sees from all of them. So you can see each individual shunt, and you can see an aggregated report of all the shunts. And the way you would usually do this is use a separate shunt than what is provided within our load centers. And our shunts are a 500 amp, 50 millivolt. That is a 10,000 to 1 ratio. So the FNDC can safely measure up to 1,000 amps per shunt. So what we would ask you to do is use a 1,000 amp, 100 millivolt shunt, or if you really are approaching the 1,000 amp mark, then go to a 1,500 amp, 150 millivolt shunt. And that is a 10,000 to 1 ratio, and we will be in sync with that. And so with the 1,500 amp shunt, normally the Deltec people who we get our shunts from recommend, basically 66%, 3/4, somewhere in there of the amount of current labeled. So, 375, 350, 366 amps on a 500. And so on the 1,500 amp shunt, you could safely go up to about 1,000 amps, and it puts it right in its power range, and it'll be accurate up to 1,000 amps. Okay, so stacking. Now this is where the bypass assemblies. In our inverters with our load center, we have given you a single AC bypass for one inverter. If you have, and this is where we kind of said, those bypasses, because we can go from 1 to 10 inverters, you could need anything from a 50 amp bypass like we provide to 100 to basically a 600 amp bypass or more. So what we ask you to do is, if you're doing multiple Radians, to not use our load centers or use the empty load centers. And that way you're bypassing a lot of parts that you don't need, and it makes it much cheaper to install than the fully populated load centers. And so what we'd have you do is use an external bypass, 2 Radians, 100 amp bypass, 3 Radians, 150 amp bypass. And so that's how we do it. And the bypass and the transfer switch would be, pretty much, one and the same. I'm going to put it on the output and bypass the whole inverter system through this bypass. And I don't know how to answer why are the green network cables that come with the hub unshielded. I don't know how to answer that, other than this is what we've used from time immemorial. 15 years we've had that same Cat 5 cable. Yeah. And normally you would have a GSC load center, one for each Radian. Now this comes down to money too. I know in a lot of foreign countries, they don't even use the GSLC. We really like you to use it. It's expensive, but it's also an attractive, and it makes things easier. And we have our DC breakers in there, which are rated for power and extremely good breakers. So basically, if you have a multiple unit, we would say use the empty GSOC load center to avoid all, having an FNDC in each one, which is a waste of money, all the AC and DC breakers that aren't needed in each one. You could get this down to a system that's a little bit more manageable money by using the empty load center.
So it looks like the next couple of questions are similar in their nature to what Lonis just answered. So the standard load center versus a special load center, there's no difference in the GSLCs. There's just how many wires come in one and versus no wires come in the other one. And then the last question here is, where can you find a wiring diagram to show all these stacked systems? So we do have wiring diagrams on our website. You have to navigate to the installer section of the website. So if you just go outbackpower.com and then click on installer and scroll down. So it is actually on the website. I know even we had some trouble finding it when we switched over. So just scroll down to the bottom of the installer homepage and you'll see a link that says wiring diagrams. And there are diagrams for several different kinds. I believe there's a couple of 2 stacks, North American. I think there might be an E on there. There's just several different ones, so you have to go look for them.
Ask for his email address.
Okay, so it looks like we got a lot of the questions out of the way. So while we're slowing down a little bit, we'll do our last poll, which is a little bit easier than the first one. It's not a pop quiz. So I appreciate your answers here. Just give us your honest answer. Hopefully you found it helpful. If not, that's fine too. Then we'll know for next time. All right, great. It looks like most everybody's voted. I'll give you guys a couple more seconds, but we're almost through. So I went ahead and closed the poll. Appreciate your answers. It looks like it was about 50-50. So I appreciate that. I'm glad you learned something. And if we could improve, we appreciate any comments if you have them. And we hope that you'll join us next time for our next webinar. So have a good week until then.